Lesson 4.2 is on analyzing linear associations. So we're going to talk about describing an association or relationship of two data sets. We've talked about it before: positive, negative, or no relationship or association. And then we're going to talk a little bit more detail about that than what we have so far. So lesson starts on 217. We're going to go ahead over to 218. So page 218, example 1, Georgia and her classmates are measuring their height and arm span. They record their data in a table. How can they determine what relationship, if any, exists between the two sets of measurements? So you see the different students, their heights and their arm spans. We don't really care about what student number they are. We're just concerned about what their heights and arm spans are, really. And what we can do, like the book does here, step 1, they plotted these points in a scatter plot. So they made a scatter plot of all these points. And the question might be, well, how do I know which one's going to be the X and the Y? It really is not going to matter too much on this problem. Some problems it makes a difference. This problem, not a big deal either way. But generally, whatever's on top in the table will make the X. Whatever's in the bottom will make the Y, if they give you a table that way. Otherwise, if it's a vertical table, what's on the left will be the X, what's on the right will be the Y. So anyway, they graphed these. If you'll notice, the numbers are pretty big here, so they actually did breaks on both of the axes. Notice the break here on the x-axis, the break on the y-axis. That allows us to graph these points a little bit easier. I don't want to graph going by ones all the way up to 67, okay? But if I do a break, then I can start at 56 and go by ones and still see all my points there. So that's the graph. So that's kind of zoomed in there a little bit since they did the breaks. And what we can do is we can try to find a trend line. Okay, so to find the trend line, we have to have a pencil. Not really. If you just have any, pencil or pen or something straight like that, you can basically try to put this by the points and see if we notice a trend, if we notice a pattern. So again, real life situation, the points are not all going to be in a straight line, probably. Okay, it's not going to be exactly perfect, but kind of looking at this generally, notice we have some points on the line, some points above the line, some points below the line. That's where we can get that trend line. And the trend line is something that gives us an idea of what's happening. We can actually use trend lines to make predictions. We could predict, like if somebody, the tallest person here was what? 67 inches. We could use a trend line and guess if somebody was 70 inches tall, what their arm span would be. Does that make sense? Okay. And so the book here then in step 3, they drew that trend line. The slope of that line is positive, and so we can say there would be a positive relationship between height and arm span. In other words, in general, if you're taller, you're going to have a bigger arm span. Does that make sense? So positive slope, positive association or positive relationship. And you can see even the book here talked about association. This lesson is called Analyzing Linear Associations, but they use the word relationship. So those words are going to be used interchangeably, so just understand we'll be flipping back and forth between those two words. So on the try it, Georgia and her classmates also measured their foot length. Use a pencil to find the trend line. Sketch the trend line for the scatter plot. Alright, so once again, we're going to try to get something that goes where we have some points above, some points below, some points maybe on the line, to get an idea of what's happening here. So we could think about maybe somewhere around here would be where we could draw a line. That's going to represent that. And you can see that would then kind of go through the middle of the points, some above, some below, to give us kind of an idea of what's happening. And that again could tell us that looks like we would have another positive relationship here, or positive association between height and foot length. Example 2, the Johannessens own an ice cream shop near the beach. Scatter plots show their sales by daily high temperature. They compare their sales by daily high temperature to the number of beachgoers by daily high temperature. Describe the associations shown. So this one we're looking at is the ice cream sales, and you can see what's happening here. Basically, as the temperature goes up, their sales go up. So that one is a positive relationship. If you'll notice though, we do have some points here that are further away. Some points are further away from the line, like over here for example, maybe over here. And so since these points are not just really close to that line, we could call this a weak association. So we could call it a positive weak association, or a weak positive association, maybe we should say it that way. A weak positive association with that. And that could be argued, that's kind of a judgment call, you know, what close to the line or far from the line actually means. It's kind of a judgment call there. And then we look at the beach visitors. Beach visitors, we do have one outlier there, but if you'll notice, those points are really close together to this line that we can draw. They're really close to that trend line, so that we could say is a strong association. It's a strong positive association. Okay, in other words, we can pretty much guess the higher temperature, there's going to be more people at the beach. All right. Again, the ice cream sales kind of follows that pattern, but not quite as tight to that line that we can draw. So it's not quite of a strong relationship or strong association as people going to the beach would be. So example 3, does the scatter plot show a linear or nonlinear association? Well, if we would try to draw a line through this, trying to draw a line, we're not going to be able to draw any kind of a straight line. There are actually other, things we can draw to give an idea of what's happening, but obviously if we try to stay close to those points, that's going to have to be curved, and that is not a straight line, so that would be nonlinear association. So on the try it, they want us to identify the associations, and besides just saying if it's positive, negative, or no relationship, if it's positive or negative, we're also going to say if it's strong or weak. Also, we're going to say if it's linear or nonlinear. So on our first equation, if we would go to try to draw a trend line here, drawing a line through these points, kind of get some above and some below the line maybe. It looks like we can draw something that's a straight line that's pretty much going to go through these points. And it looks like this line would have a positive slope. It looks like the points are all pretty close to that line. So for this one, we could say that's a strong positive linear association for our first graph. Strong positive linear association or relationship. If we look at our second graph, on the second graph, these points are kind of just scattered around. I can't really even try to draw a line that's going to go through. So this we could say is going to be nonlinear. And then also, since there's really no pattern, no rhyme or reason to where these points are, then we would say that's no association. So nonlinear, no association. If it's no association, we're not going to say strong or weak. We only say strong or weak if it's positive or negative relationship. And if we look at our last graph here, so our last graph actually has the same answer as what we had on the second graph. It's going to be nonlinear and no association. When you do these, if it is no association, it's always going to be nonlinear. Okay? So those two go together. So the key concept, just kind of recapping things again, we can talk about, besides positive, negative, or no association here, strong, positive here, strong because they're all close to the line, weak, positive, weak because they're further away. That one's getting borderline to no relationship maybe, but there are quite a few points right along that line, so we're probably okay there. And then this last one, you can see that would kind of curve, and so that one would be nonlinear. So if we look at the do you know how number 4, they want us to describe this association. So again, looking at these, trying to think about if we can draw a line that's going to kind of represent these points. And then if we can, thinking about if that's positive or negative relationship, and then whether it's strong or weak. So this one, we can probably think of drawing a line somewhat this direction, get some points above, some below, maybe some on the line. That has a positive slope, so that would be a positive relationship. The points aren't just really super close to that line, so we could call that a weak positive association. Weak positive. If we look at number 5, this one is not a straight line. We could try to draw something that goes along these points, but it's going to be kind of all over the place. It's going down and then it's going up, so that would be nonlinear. And again, if it's nonlinear, we're not going to worry about calling it weak or strong. We'll just say nonlinear. And I guess technically we could say no association as well. Workbook page 53, number 1, they're asking which line is the best model of the data. So we're trying to look at these points that they've given us here. Based off of these points, which of these trend lines is the best for representing those points? And so it looks like out of the options given, line P here would be the best model for that data. So line P would be our answer for that problem. Number 2, they're asking if it's a positive, negative, or no association. And this one, if we try to draw a line kind of through these points, you can see that would have a negative slope. So this would be a negative association. And if we want to be more specific, we could say it's a strong negative association. Those points are pretty much right on the line for that one. Number 3, they don't give us a graph here, but we're just thinking about with this information whether this would have positive or negative association. So the age of a car and the reliability of a car. So if you think about if a car is older, so if its age increases, what's going to happen to its reliability? Well, generally, if the car gets older, it might have more issues, not be as reliable. So age of the car goes up, reliability of the car might go down. And so if you can imagine on a graph, if we would graph this out, if this is our age and this is our reliability, so as the age goes up, the reliability is coming down. So that would have a negative association. What you can think about is if these arrows or if your thumbs are going opposite directions, that's going to be a negative association. If they're going the same direction, that's going to be a positive association. So number 4, treadmill running time and calories burned. So if our running time goes up, if we're running more on the treadmill, calories burned would go up as well. So this would be a positive association or a positive relationship. Number 5, describing this relationship. We could kind of draw a line going through these points here, something like that. So that we could call a negative association. We're going to be more specific here again. These points are really not all super close to this line, so we could call this a weak negative. And if it's positive or negative, it's always going to be linear. All right. Weak negative linear association, we could say. Okay, if it's no relationship, then it will be nonlinear. Positive or negative, it's going to be linear. Number 6, trying to get a relationship there. Starting out, it looks like we're going to have a negative relationship, but then this end part, it's kind of leveling out. And so that one would probably be we could say no relationship. And we could say nonlinear. Okay, it's not really making a straight line here, so you could possibly argue like for a weak negative somehow, if you really tried to get this to work. But like I said, that end part where it's just really leveling off right at about 200, that's kind of giving a hint that this is actually going to be nonlinear and no relationship. Number 7, a business manager was hired 9 months ago and wants a raise. The scatter plot shows the number of new customers the manager brought to the company. Draw a trend line for the scatter plot. So first of all, looking at the information here, draw a trend line. So something like this maybe would be a line. Notice we've got some points above, some points below, some points are right on our line. And then what type of association does that show? Definitely have a positive relationship here. Specifically, we could probably even call it a strong positive linear association. And then number 6, use the information from the scatter plot to explain why the manager should or should not receive a raise. So this is the number of months is our X, and then the number of new customers. So you can see, as time's going on here, they're getting more and more new customers every month. And so that would probably indicate that they should receive a raise. So something like this, number of new customers tends to increase each month. So based on this data, the manager should get a raise. Number 8, they're asking for a real situation that will show a negative linear association. So negative association, things are going to be doing opposites of each other. So one example that we could give would be the temperature outside and your heating bill. Heating bill. Okay. So if you think about this, temperature outside goes up, so it's warmer outside. Your heating bill would go down. Okay. Heating bill, not air conditioning bill. Okay. And then another option you could think about it, the temperature outside goes down, so it's getting colder outside, your heating bill would go up. So again, both cases, these are doing opposites of each other, and if they're doing opposite things, when you go to graph those, that would be a negative association or negative relationship. Number 9 asks, how do you know if a scatter plot shows a nonlinear relationship? So if we can draw a trend line, that does not mean it's nonlinear. The points form a curve or circle. If they form a curve or circle, that would be nonlinear. If they form a line, obviously that's linear, not nonlinear. No association between the data points. And really we could argue for that one as well, actually. So I'm not sure how great of a question, A, B, C, D, we should be just choosing one of these. But actually I think either B or D would be a fitting answer there. So this gives you an idea of how to analyze linear associations.